Yeah, they are.
Yeah, we're gonna get started today. Hopefully we're a little bit more familiar with our training chart. That will help in our plotting later today in class. But first we're gonna go over our aids to navigation. So I did want to show you on the, on the Google Classroom. I'm trying to bring it up here. Okay. I usually try to hand this out, but we're not handing it out. It might have been mailed to you. A quick guide for aids to navigation. That's ATON. And it kind of has, what does it have? It has 8 pages, a little quick guide of buoys. As we go through our PowerPoint, you might want to look at it. It might be helpful just as a quick reference guide. So I do have a couple aid to navigation guides and pictures on there for you. But I don't know, did you guys get that in the mail when you got your other workbooks, or no?
No.
Okay.
No.
A lot, I think they sell in the store, but a lot of, West Marine type places will have it on a little card too, like a waterproof card. That's a quick reference as well, which is always good to look at. Excuse me. Let's see. I will do new share. All right, so you guys can see my PowerPoint now, right? Yep, okay. So yes, today we're doing aids to navigation, and then we'll be plotting. I did want to go over, let's see. I think somebody had a question last week about the different zones, if you will, the different boundaries. So I did want to show you a quick, there are a lot of different boundaries in different areas you could say you are, or limits, if you will. So closest to land, we have our demarcation line, and that goes between your international rules of the road and your inland rules of the road. And then you have a 3-mile zone, which really doesn't have too much of a significance, I don't think, but it is on your chart. The territorial sea is 12 miles out, and that one I would say is your that says 3 still, that means 24. Your territorial sea is kind of, I would say, like your California boundary. And you have to be, for like practical purposes, you can use your OWS, which is your oily water separator, right? You don't want to pump just pure bilge water and oil overboard. You want to separate it and clean it first. And you could also throw food, but your trash has to be ground if you are using that. Also, I found out on three nautical miles was you can't use an incinerator. That's another way of disposing of trash on board, is by using an incinerator. So those cruise ships and other commercial vessels can't use an incinerator within 3 nautical miles. The contingency is 24, not 3. I need to edit that. 24 nautical miles. And that one is where we get a lot of our one's called CARB, C-A-R-B. That's a California zone for burning fuel. And then, so basically your fuel pollution, air and water pollution acts can either reference your territorial sea or your contiguous sea. So yeah, you're 24 or you're 12. The EEZ is where the ECA is, and that is more stringent than the what is it, the CARB zone for California. So you have, or commercial vessels at least, have to switch to clean fuel and clean anything going overboard at the 200-mile zone, because that's what the more stringent rules, the eco rules are. And then anything beyond that would be considered your high seas or your blue water. Sometimes it's referenced as. So those are your kind of your zones. And they are all on your chart. So you can see them all on your chart. You have your 3 nautical mile, your 12 nautical mile, your 24, and then your EEZ is also, your EEZ one has a little fish on it, and it's also the international border as well. So the EEZ border, you can see, very clearly between Canada and the US and Mexico and the US. And then you have your demarcation line, COLREGs, and that's on the chart as well. This is the picture of it as a international border. You have the dash with like a little line on it for an international border, where if it's just 200 miles offshore, it's just your gray boundary line with the fish. Okay. This one I was showing you, you have your 3 mile, your 12 mile, and then your 24 mile. So they're on the chart there. And it says see note X, which you can read note X, but it's very just in reference to different laws. But really, I don't know. I didn't find out too much information on it. So let's dive into AIDS navigation, so we can get into our plotting, because I know we all want to practice our plotting tools. Okay, so we are going to start with, we have 2 buoy systems. We have cardinal systems and lateral systems. The cardinal system kind of marks a general area, and I'll specify those when we get to it. Your lateral system of buoys marks your channels, your way to stay in the channel and follow whatever, kind of your road or your side blocks to your road is your lateral system. So that's going to be for you to follow a specific channel. And within the lateral system, we have IALA A and IALA B. So let me show you that. So if we're in the United States, or South America, North America, and then we have Japan, South Korea, and the Philippines, we are in IALA B, where we have that red right returning. Has everyone heard of the red right returning poem or phrase? People say it a lot. If you are in Europe or anywhere else, Australia, South Pacific, you're going to be in IALA A. which is our green right returning. So you definitely want to know which area you are in, because that red right returning won't work on everything. So that's just a, yeah, just a friendly reminder on that one. We are in Ayala B, so we are going to focus on Ayala B for the rest of class. But I will show you the difference between Ayala A and B when we get to that point. But we're really just going to focus on our red right returning Ayala B, which is North and South America. So we have on our buoys have different characteristics. There's the shape of the buoy, the color of the buoy, the numbers or letters on the buoys. They have all these different characteristics of what a buoy looks like. And that can tell us information of, do we keep on our right side or our left side, or is there a danger? Is there not a danger? You know, what is this buoy here for? What is it telling me? All of these little things can help me figure out what that means. So generally speaking, for our Ayala B, when returning from sea, so if you're at sea and you're coming back to the dock, so you're seaward and you're going inshore, that's where we're going to have our red. We're going to keep our reds to the right when we are returning. And yeah. These are other poems, I guess. Your even numbers are your red buoys. Your odd numbers are your green buoys. Your even numbers are the nun shape, which we are going to look at, which is just a pointer version, where your green is going to be squared off. Nice square looking. So the poems are even red nuns have odd green cans, red right returning, and some people have the cogs turn. Cans odd green to starboard, red nuns. I don't know what that other ones are.
I think that's supposed to be TERN.
Oh, I was like,
triangle even, red.
Triangle and even. That's it. There we go. Okay, we have our Ayala A and Ayala B. Guess that's a little out of order here. So Ayala A, instead of red right returning, their little poem is red to red or green to green when we're returning. And that's in reference to their side lights. So your red side light is next to your red buoy when returning for your Ayala A. So red to red or green to green, or red right returning for Ayala B. So I guess we're going A and B's here. So B, this is our main, what we're looking at here. We have on our green side, you know, it's squared off. So those are our can buoys. And we have top mark, which is the shape on the top of the buoy is square for the port hand side, the green. On our right side, we have triangle or the pointy. That's what we're going to refer to as the nun or a triangle for our starboard side. And I will talk about the preferred markers when I get to that chart. But if you look here for the Ayala A, the shapes, you know, you have your square for the port and pointy or triangle for your starboard or right hand side. Those shapes are still the same. It's just the color that's opposite. So it's only the color that's opposite for the different regions. Okay. We're going to dive more into buoys in a second, but first we're going to go for lighthouses. So your lighthouses can have a bunch of different characteristics, and this is all for correctly, the whole point of all these different characteristics of buoys and lights and aids to navigation in general is to correctly identify what's on the chart to what you're seeing with your eyes. So there's no point of, you know, getting a position off of something if you're thinking that it's something else. That's not going to help you. So you really want to correctly identify what's on the chart to what is it that you're looking at and you're using as your aid to navigation. Are you using it to get a position? Are you, keeping it to the right or to the left? Is it the same thing of what you're looking at on the chart? Excuse me. So for lighthouses, they can have all sorts of different characteristics, going from the actual structure itself to the light characteristics. Some can have those, radio beacons. Some can have raycons. There can be lots of different instruments on the towers or the lighthouses themselves to really correctly identify what lighthouse you are looking at to what it is on the chart, so you can see it. So does anyone remember where I would get a description of the structure of a lighthouse besides on the chart? I'm looking for a coast pilot.
Coast pilot.
Found in the light list or the coast pilot. So that's where it had, a real good description, plain English, not just little abbreviations that you're going to see on the chart, of, sentences worth of description for each, lighthouse or aid to navigation that way. Because, maybe, I don't know, Disneyland or something erected a lighthouse that looks like a lighthouse, but it's not technically an aid to navigation, right? It's not on the chart. It's not specifically used for navigation. So you might have these landmarks and you're like, oh, it's the Pink Hotel, or I don't know, whatever it is that you see as a landmark from the water because you recognize it. But if it's not on the chart, we can't use it as that aid to navigating. So we want to look at that coast pilot and that light list to really find what we're looking for to help us navigate. So there's the lighthouses. This PowerPoint seems to be all over the place. Skipping this one. Let's talk about buoys again. Okay, so our green buoy, which is going to be if we're returning from sea, it's going to be on the left-hand side, and it is going to have that square shape. So it is going to be very right-angled square shape. So if it's a floating buoy, it's going to have that can. We call it a can. That way, any direction you're looking from it, it is squared off on the top. It has that can shape. They are all going to be green, and they are all going to be numbered odd. So you have your odd numbers. When it's on the chart itself, we have two different lines that are describing it. The first part is describing the physical buoy itself. So this buoy here is saying the buoy itself is green, and in quotes, it has a number 9. So there's a physical 9 on the buoy. And then it has a light because it has that magenta stamp, I call it. It has that magenta circle around the circle of the buoy. So it has a light on it. If it doesn't have a light, it doesn't have that magenta stamp. Now, all of the lighted buoys are going to have a magenta stamp. It doesn't mean that it's red. It just means that there's a light on it. It could be a white light, could be a yellow light, could be green, red, whatever. It just means that it has a light. So that second little line here is describing the light of the buoy. So it is saying the light is flashing. It's a green light and it's flashing every 4 seconds. This case is a fixed light because it is fixed to the ground. It is flashing green every 6 seconds. And it has a quote 1. That means there's a physical 1 on it. That's what you're going to be seeing, a number 1. Of course, if it's dark, you're not seeing the number, so you see the flashing the light characteristic. And then you have a dayboard that just has a number. But those are our types of, our most common types of buoys that you'll see.
Obi, can you go back to that slide real quick?
Yes.
The second buoy. See, I was thinking that was, why did they have that redundancy? You know, G, number 9 in quotes, flashing G again.
So,
but that's saying the light that's flashing is green.
Correct. The second line is talking about the light characteristic. The first time is talking about the physical characteristic of the buoy.
Of the buoy itself. Okay.
The whole buoy itself is green, okay, and it has a green light.
Okay. Are they typically the same? The color of the buoy and the color of the light?
I'm going to say for red and green, yes, but then we have all of our other buoys that have different colors.
Yeah, right, okay.
And with yellow, you know, most of our yellow buoys are going to flash yellow. We have our, we'll continue on. That question will answer itself.
Yeah, that's fine, okay.
Okay, so you have your buoy that doesn't have, so if you have a buoy like this, its shape isn't giving you an indicator. If it has a top mark on board or on top mark on top, that would be the square. This one just has light because it's a cartoon, but yeah, if it has a top mark, it would be the square. You have the cylinder or a pillar buoy, but again, kind of squared off, even though it's a circle. Your ones on the right side are going to have, you know, more of a triangle shape, more of a pointy shape, and that's going to be your nun buoy, which isn't exactly pointy, it's flat on the top, but just in general, if you think pointy, that's your right side. So again, you have your shaped buoy, the nun buoy with the number 6. So the indicators here are saying that the buoy itself is red, the shape is a nun, and it has a number 6 on it. For our light, our day-shaped light, it has a number 2 on it, and then it's giving us characteristics of the light itself. Flashing red every 6 seconds. So that's the light itself. If it's just the day marker, you just have red number 2. And then you have your buoy with no top marker or anything. Is just saying the buoy itself is red, it has a number 8 on it, and then you have the light characteristic. So we have different types of ways of indicating where the channel is. These are all part of our lateral system.
Question on that?
So this is just a picture of a dolphin. People were asking what a dolphin was at one point. It's just a way of putting something that's fixed in the water. So yes, this is a fixed light because it is anchored on the sea floor, or it's not anchored, I'm not gonna say that. It's fixed because it's attached to the sea floor and it's not affected by tide. It doesn't have, not all fixed lights, have to have a dolphin on it, but it's just a way of having that fixed versus buoy, which can be floating around. Of course, it's anchored with a tether to the floor, to the sea floor, but it is affected by tide. It can move around slightly. So yes, you can have a light that is, not on land. It is still fixed to the floor. Okay. Man, I feel like this whole thing is out of order, but we'll go with it. Any questions on our numbered buoys so far?
I have a question.
Yeah, go ahead.
So on this chart, when you're looking at buoy number 8 is not none. It's red and has a square top. Is that possible?
That right here is what you're talking about on the slide?
Number 8. Yes. Number 8.
So, yes, number 8 buoy doesn't have a specific shape. That's going to be your buoy that looks like this. So it doesn't have its shape. Its shape is not giving you keep it to the right or keep it to the left. So those are used for sure. If it has a top mark, which, let's see if I have a picture.
So a non.
Okay, so here's
a non-none red buoy doesn't mean keep it to the red right return. It has to be none to be red right return.
No, if it's red, it means keep it to the right.
Okay.
So this is an example of the bifurcation buoys, but you can see this buoy on the left here has no top mark, but it's still definitely an indicator of what to do. This buoy has a cone-shaped, that triangle-shaped top mark. So you're treating it as a green. This one has the squared off top mark. You're treating it as a red. But some buoys don't have it.
How are you treating this one on the left, the one with the critters on it? The one on the left, how are you saying you're treating this one?
We're treating this one as a red because it's red, green, red. But I'm going to get into what bifurcation means in a second. I just wanted to show you an example of the top marks, and some buoys have them, some buoys do. I'm trying to see. But yeah, if a buoy doesn't have it, it doesn't mean that you treat it differently. So it's a lighted buoy and it's red, so we're going to keep it to the right, even though it doesn't have a shape characteristic with it. If it did have a shape, it would be cone, but it doesn't. And on the chart, it would tell you that it has a top mark that's a cone. So it would indicate that as well, but this isn't indicating any top characteristic at all. Did that kind of answer your question, Eric?
It answers the question, always keep red to the right on return.
Yes.
But it doesn't really answer the question, what is a none shape versus not none shape? What information is a none shape versus a non-none shape red buoy? But the most important thing I think at this juncture is keep the red to the right.
Yes, definitely keep the red to the right. I want to ask, maybe Robert knows, in different areas, you might have a shaped buoy, can or none, that doesn't have a color. I want to say maybe the Mississippi, but maybe that's wrong. Do you know?
The river system used to have red and black, I think, or green and black. I forgot which it was, but
So if it doesn't have a color that indicates which side to keep it to, but it has a shape, then you're following the none. But that is not seen typically at all.
Yeah.
You might be in some crazy backwaters that might have a buoy with a shape as none or can, not a color. I'm going to say 99% of the time you're going with color. Hopefully that, yeah. Okay. Okay. So also, we have our red right returning, but we also have our numbers on the buoys. So we have our even numbers are to the right, our odd numbers are on the left, and they start seaward as small numbers. And the closer you get inshore, the higher your numbers get. So we have this returning, your numbers will be increasing, but we also have a system or a direction, if you will, for intercoastal waterways, or for, I guess I'm just going to go with intercoastal waterways. So typically, again, 90% of the time, you're going to see that the numbers will be increasing from your sea buoy out seaward and getting bigger and bigger as they go closer to shore. If we are traveling in an intercoastal waterway where we're not following going into shore, but we're following along the shore, which is more common on the East Coast, less common on, you know, southern West Coast, but we do have our inland passage through Canada and straight to Juan de Fuca up there, Puget Sound. But if we're following those directions, we're going to go clockwise around the United States. So again, it's increasing headed south, and then increasing headed west, and then increasing headed north. So if we are following intercoastal waterways, that is our kind of our returning from sea is going to be headed south or headed clockwise. Let's just go with clockwise. I need to rearrange these slides.
So I have a quick question. So
Yes.
the buoys in the, you know, out in the kind of open water, they'll be increasing as you're getting closer to shore, you said, or going this direction. Then once you hit the channel, they kind of reset, right? And start over.
So here I'm talking about your lateral marks, which are really going to start at your channel. If you're talking about like or buoys that are out in the middle of the ocean, not in the middle of the ocean, but some are, those are going to be indicating something else, and they're most likely not having a number.
Oh,
they're going to be lettered,
right,
giving you an indication of what they mean by letter.
Okay.
Recording in progress.
Okay, so now we're going to talk about some other buoys that aren't this doesn't make any sense. We're going to talk about some more buoys. So our first one we're going to talk about is our safe water mark. Our safe water mark is typically the start of your channel. So we have one right at the opening of the Newport Jetty. We have one in Long Beach. We have one on the LA side. Kind of right when you're entering a channel, you're going to have the safe water mark. And it's indicating that you have safe water, that there is open water on all sides of this buoy. You can be approaching it from the south, you can be approaching it from the north, from the east, from the west. Wherever you are, you can be headed directly towards this buoy. And then, so it's great for voyage planning in that way, where you can head directly for the safe water mark. And then once you get to the safe water mark, you can head into the channel, keeping, your red on the right-hand side. Or you can, as you're leaving, you're headed for the safe water mark. You don't want to, cut the jetty too close and just, oh, I passed the end of the jetty, let me turn. You want to head all the way to the safe water mark where it'll be safe water all around, and then you could head to wherever direction you're heading to. So it's typical to voyage plan from safe water mark to safe water mark from wherever you're going. So for your safe water marks, they are always going to be vertically striped, red and white. So before we had that full color, now you're going to have vertical striped, red and white. And we have the indicator of the color, R and W. So that's indicating the color of the buoy itself is red and white. And then your safe water marks are always going to have a light characteristic that is Morse code A. So Morse code A is DIT-DA. So it's a short flash and a long flash. Short flash and a long flash. It doesn't have a timing mechanism on it. It's just short, long, and then it'll pause for a little bit and go short, long. But there's not a Morse code A every 5 seconds or 6 seconds. You don't have to time it or anything like that. You're just going to see a white light quick and then a white light long. Quick and long. So your white light is kind of your starting point. That's your safe water mark. And then you're following your red and your green lights as you're going into shore, or you're following your red and greens out. You pass the white light and then you're in open water. Your safe water marks will have a letter on it identifying it. So in our case for Newport, we have the NWP. So that's just your Newport safe water mark is your NWP buoy. Sometimes it's just one letter, sometimes it's 3 or 4 letters. But that letters are helping you identify the buoy. Besides it being vertical, vertical striped, red and white. And then if you have a top mark on it, it's going to be a cylinder, spherical top mark. So here are some pictures. I should have the NWP on here, which I have. But you have your vertical striped, you have your white light, and then if you have the top mark, it's going to be a cylindrical circle top mark. So those are your safe water marks. Any questions with the safe water mark?
Yes, how far away from the, say, mouth of, well, the say Newport is that buoy?
I don't know the exact distance, but it's pretty close. It's not like 3 miles out or anything.
Yeah, it might be. I think it's less than a quarter of a mile, like a few hundred yards, maybe.
Yeah, I wanted to say like a couple hundred yards. It's close. You can see it. Like if you go to Corona del Mar or something, you can see the safe water mark.
I have a question, not specifically on the safe watermark, but the lettering or the, just the symbols. What one indicates a top mark on the buoy or whatever it is?
That's
Like they
going
look
to
the
be
same to me.
Hold on a second. The circle on the top. Oh, because the sphere doesn't have a top mark.
Oh, okay.
Sorry. I'm gonna get a better picture.
Yeah, I think I did see something that, but then it looked like there was a circle, but maybe that was a sphere one, so it didn't have the actual top mark.
Okay. Sorry. Why isn't it giving it to me? Okay. Copy. Bear with me a second. Okay, safe watermark, share screen. Okay, so back to our safe watermark screen. So this is our NWP buoy. What we see on the chart is it's red and white. It doesn't have that top mark shape, that little circle on top of the buoy, because there is no top mark on our NWP buoy. It has NWP because that's what it has on the buoy, and then it has the white light. It is white light. I know that it's a white light, one, because it's a safe watermark, and two, because it doesn't give me a color. If there's no color indicated on the chart for the light, then it's a white light. So if it doesn't say it's yellow, it doesn't say it's red or green, it's a white light. You will see on the training chart, it will say white, but on modern charts, it does not say white. The default is white. It will specify the color if it is not. As a little indicator here, this is how far, I mean, I don't have a scale, but here's your jetties and your day marks on the end of the jetty, and then that's where your safe watermark is. So you want to aim for your safe watermark and then head into the channel, or head out of the channel, past your safe watermark, and then head, to the north or south or wherever you're going. So
you say, okay, the NWP, I see that lettering on the buoy itself. You said RW.
That
is-
is indicating the characteristics of the buoy itself.
It's
It is
red and
vertically
white.
striped,
Just
red and white. Yes.
NWD, then MO.
MOA is the light characteristic.
Okay. Oh, the top. Okay. Okay.
So our light is always going to be white, and it's Morse code A.
Oh,
Instead
got
of
it. Okay,
quick
got it.
flashing,
Yeah, all right.
it's giving you a light characteristic of Morse code A.
Got it. I see. Okay, thanks. Okay.
Okay. Now we're going to talk about preferred channels. So let me scroll down to my preferred channel picture here. So this is kind of our lateral system. We start with our safe watermark at the most seaward side, and then we are going inshore, and our red is on our right-hand side. Our green is on our left-hand side, and our numbers are increasing as we are going inshore. So if we have a secondary channel that it is saying it's safe to go this way on this side of the island, but the preferred channel is to stay, the main channel is to stay over here in the like dark black line. But you can still use the dashed line. That's still navigable if you're going that way or whatever reason it is. So you have this secondary channel, and how it is identified is by a bifurcation buoy. So this buoy here is our bifurcation buoy. It is saying if you want to stay in the main channel, it is mostly red. So keep it as a red buoy. But it has this green stripe, horizontal stripe. So our bifurcation buoys have horizontal stripes. It has a green stripe on it saying you can treat it as a green buoy if you want to go into the secondary channel. And so you have your green, and you can follow the secondary channel. So again, your safe watermark starts the channel. And then if you want to go in the main, we keep our red to the right, our green to the left. But if we have a bifurcation, that stripe is telling us the secondary. That stripe is telling us, do we want to keep it to the left or to the right? So let me go back to, again, I feel like all of these are out of order. I don't know why. Your preferred channel markers. So yeah, the preferred channel was to keep all the reds on one side, all the greens on the other. But if you want to go to a secondary channel or not preferred, then you can treat it as whatever color the band is, essentially. So if we want to go to the left, it'll look like that. If we want to go to the right, it'll look like that. Their light characteristics are always a composite. So you have a flash, flash, and then another flash, 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 and then another flash. If you want to treat, the main way to treat this buoy would be as a green buoy. So it has a green light and that cylinder, that squared off top mark, if it has a top mark. So its main way, if you're going to preferred channel, you're using the, most of the color. It's green buoy. Use this as a red buoy. If you want to go the secondary, the less preferred channel, you can use what the stripe color is. You can treat it as a green buoy, or you can treat this one as a red buoy. These are your examples. So how I was saying, I was treating this one as a red buoy. It has the, you know, that's squared off, and it has, you know, red. I was like, red is supposed to be triangle. So this must be in international waters for the shape of the buoy itself. Changing that to. Okay, so if it has a top mark, I mean, this one they're treated as green because it's green, red, green. This one we treat as red because it's red, green, red. Again, red, green, red. So those are our preferred channel markers. And I guess what I don't have on here is, oh, it'll be, sorry, I'm going to go back to this. On the chart, it will look like this. It will say red and green. So that top line, again, is describing the characteristics of the buoy itself, the physical characteristics. So it is saying it is red and green, and it has the red first because it is red, green, red. It is mostly red with a stripe of green. And that's our red and green buoy. And then it gives us the light characteristics of a red light. So if we want to stay in our main channel, we treat it as a red buoy. If we want to treat it as a green buoy, we go to the secondary channel.
So this one's a little confusing. Up there in the upper right, you have the green on the right and the red on the left. Is that like a one-way channel? I mean, if you're returning, so go up and to the right there.
This area?
So yeah, how do you go into there? You can't keep the red on the right. Is it kind of a loop or a one-way road, so to speak?
Yes, in this picture here, it is talking about the intercoastal waterway.
Oh, okay.
So that intercoastal waterway again goes from north to south on the East Coast, goes west, and then goes south to north on the West Coast. So in when we're looking at the intercoastal waterway, and I know with this mixed slide thing, it'll be here somewhere, but we can treat it, when we follow the intercoastal waterway, we're following the little yellow.
Oh, yeah, okay. And
So
it's like seaward side or inland side of the channel or the waterway.
Correct.
Okay.
So we have our squares.
Yeah, I mixed those guys.
And then our triangles. Okay. I am so mad at this PowerPoint. Another buoy that we have is an isolated danger mark. So this is talking about an isolated danger. It's not giving us a direction or anything. It's just saying that there is a danger below this buoy. It doesn't give us an indication of what that danger is. It is a wreck, is it a reef, it could be anything. You just have an isolated danger. You'll have your two top marks. Let's see. No, you'll have your two top marks are your spheres, and if it has a light, it will be white. So let me go back to this picture. Our isolated danger buoy is over here, and we have the double top marks, and it is mostly black with a band of red, and it has a light on it because it has that magenta stamp. So the light is flashing two flashes every 5 seconds. So if we're looking at it, it looks like it's on the wrong side of the island there, but we have our isolated danger buoy. So we have red or black, red, black with our 2 top marks. And this one says that there's a light on it. So that is our isolated danger mark. There's another example of one. Has our top marks, has a light, black, red, black. Okay, then we have our special purpose marks, which can be lots of different things. Certain anchorages, traffic separation schemes, military areas, just some sort of special purpose. They are going to be lettered. The buoys themselves are going to be yellow, and the light is going to be yellow. So again, buoy itself will be yellow, and your top mark will be an X, and the light, the flashing light, will be yellow. Here's some of the special purpose marks. They can be a can or a none, unlighted buoys with letters, yellow light. Yeah, that's your yellow buoy. It's not giving a direction of direction of the buoy. I'm going to say it's not really giving you keep it to the right or keep it to the left. It is a special buoy. We do have them. We do have one marking the traffic separation scheme of our traffic lanes going north, but not our traffic lanes, or I guess if you're at Long Beach and you're headed up to Santa Cruz or north, those traffic lanes, they do have a special purpose mark, but our other traffic lanes do not. So it's not like any traffic lane you're looking for a special purpose mark. They can be there, they don't have to be there. It's just, I don't know who decides where to put these things. Special anchorages, definitely seen them for anchorages. Yeah. Then we have our information or regulatory buoys. That's typically where you'll see the, speed limits or, no jet ski area, that kind of thing. If they have light, they'll be white. So that's good to know. Okay, and then we have how we talked about our lateral system and our cardinal system. Our cardinal system is indicating a hazard in some area. So this is different than a isolated danger buoy. This is your cardinal buoy is indicating safe passage. So it isn't necessarily indicating danger, even though there is a danger there. It's indicating where the safe water is. So if you see, so there's 4, safe passages. Pass it to the north, to the south, to the east, or to the west. So if you see, let's describe them first. If you see the buoy with a black and then yellow on the bottom, and your top marks are 2 triangles pointing up, that means your safe passage is to the north. If you have the band where it's black, yellow, black, and it makes a diamond, your safe passage is to the east. If you have your triangles pointing down, yellow on top, then black, your safe passage is to the south, etc. West. It looks like a wine glass for the west. Your triangles are pointed together, looks like a wine glass. Safe passages to the west. It also has the light characteristic that I would say is associated with the clock, right? If you want to go to the east, it's 3 flashes. If you want to go to the south, it's 6. If you want to go to the west, 9, or continuous flashing to the north. So this guy on our left, which way would safe passage be?
The east.
Quiz. The east, because we have black, yellow, black, and we have that diamond shape. So this one has the 3 colors, black, yellow, and black. Now this guy on our right, where would safe passage be?
South.
To the south. We have our triangles pointing down, and we have our yellow, and then our black on the bottom. So those are your cardinal buoy systems. I have not seen these cardinal buoy systems on the US West Coast. It is more of an international buoyage system.
Buoyage.
Was there a question? Okay. Okay, so all of these buoys that I have gone over are going to be on your quick reference guides. So I would definitely just try to familiarize yourselves with those quick reference guides. That way, if you have a question, you know, you can look it up real quick. Again, I'm pretty sure our bookstore has like the waterproof versions, but on the Google Classroom, I have like a 6-page one. I mean, you only need like 1 page, but I gave you a bunch of them. So check that out. Okay, now I know I briefly talked about this earlier. We're going to talk about that intercoastal waterway. See, we had this slide before. I don't know why it's back again. Your intercoastal waterways are kind of, again, like a secondary, maybe even third to other passageways, right? So your main channel is in orange here. You keep your reds on the right, red right returning, your greens are on the left. But if you are following an intercoastal waterway, which would be the blue one in this case, you can follow it keeping the triangles on your right and the squares on your left, and you're following the little yellow marker on the buoy itself. So as you can see in this picture, I think I zoomed in here, you have the little yellow triangles. So we're following, even though this is a red buoy and this is a green buoy, we're treating them both as red, following that intercoastal waterway. So you want to know, you know, this is all prior to voyage planning, you should be able to, or when you're voyage planning, you should look around and see what buoys you're going to be following. That way you can expect to see the little intercoastal marker or not. We already went over this. Okay, this is an example of different light characteristics that you'll find on the chart. You had group flashing, single flashing, you know, fixed, all sorts of different continuous, quick, Morse code A, all sorts of different groups of flashing. This is both in the light list where it talks about all of the lights and in the chart 1. So you should see it in chart 1 because the chart is telling you this, you know, OC or ISO or
Chicken tongue.
flashing
Easy chicken tongue.
characteristic, but it's also in the light list as well. So if on the light characteristic you see something that you don't recognize or don't really know what that is, you can look it up and see, you know, what the timing is of it. That being said, when you're looking at your light characteristics, and it says 6 seconds or 10 seconds, that's from the beginning of the cycle to the beginning of the next cycle. So if you have a light, let's say it's flashing every 6 seconds. And then you have another light that's flashing it's flashing red every 10 seconds. So, or we can say flashing once. Oh, let's mix it up. Let's say it's flashing 2 times. And let's call this one flashing 3 times. So you're going to have a flash and a flash, and then 6 seconds, and then another flash and another flash, and then 6 seconds. So your 6 seconds isn't, you know, empty space. Let's so go with our 3 second one. We're going to have 1, 2, 3. From the beginning to the beginning of the next one is your 10 seconds. Does that make sense when you're doing a time? Okay. Go back.
So I think there was some that didn't have that time or that number of flashes. So if it says, for instance, FL or FR,
then it's
and it just says
flashing.
one pulse. Okay.
So if it's just flashing, then it's just a single flash. If it has the group flashing, that's when it's going to have a number next to it.
Yeah, thanks. That looks good.
Okay. Let me see. Okay. We're going to do some light, some determining the range of light, and then we're going to go to our break. Okay, so determining the range of a light. I wanted to see if I had an example of what it looks like on the chart.
There was one on assignment 2, if I'm reading it right, question number 10 might be an example of that.
So remember, our light is always a solid dot, where your buoy is an open dot with a diamond. So your light, I'm just going to copy a light characteristic from the chart here. We have FL 5 seconds, 36 feet, 13 m. So this is an example of what we see on the chart. Now, if we look up in our light list, we can get more description of what the physical, characteristic of what this light will look like. Is it a lighthouse? Is it a day marker? Is it, what kind of light is it? From this, all I know is that it is fixed, right? It is fixed to the earth. It is not moving. And it doesn't tell me a color, so I know that it's going to be white. It is fixed. It is white. It is flashing every 5 seconds. So it just has a single flash every 5 seconds. And then it tells me some information over here, which is what we're going to look at when we're questioning the range of the light. How far away can we see it? So again, this is describing the light itself, characteristics, and then this is going to be talking about how far away we can see it. So this first one gives us the height. The height of the light. So if you had a light that was, if you're standing on the beach with a floodlight versus you had a light 200 feet up in a lighthouse, you're going to see that light a lot further the higher it is. I'll go over that. But that's why we want to know what the height is. And then this guy is telling us the nominal range. And I will go over what all of these terms are. But we have a nominal range. So let me go to my slide. Okay, so on our slide, back to the PowerPoint here, the 3 things that we want, where we are given and we want to identify is first our nominal range. So that's what comes from the chart. That's that number on the chart that has the M next to it. And it is telling you basically in perfect visibility, which they are considering 10 nautical miles. So if, the weatherman, KTLA says visibility is great out there, then, it's more than 10 miles. Whatever it says on the chart as your visibility, that's the visibility that you can, see on the, if it's perfect visibility, your nominal range is right on. If it's not perfect visibility, if it's foggy or hazy or whatever, that nominal range is going to be lessened somehow. So I like to call it an intensity indicator. So if it is a super bright LED light in perfect visibility, you're going to be able to see it way far out. If it is kind of a dull bulb light, you're even in perfect visibility, you're not going to see it that far away. So it really is a great indicator of the intensity of that light. How far away in perfect visibility are you going to be able to see that light? That is what the nominal range, the number on the chart, is giving you. So we're going to use that number and apply our meteorological, can't say that, visibility. So what is our visibility out there? We can use, a weather service, an app. What I typically do on board is try to use a radar. And if I can see on my radar that there's a target out there at 20 miles and I can see it, then visibility is 20 miles plus. if I have a target that is 10 miles and I can't see it, then visibility is less than 10 miles. And I'll try to watch it until it gets closer and closer and I can see it and be like, okay, visibility is 6 miles or whatever it is. So you can determine visibility by comparing something that you know, like, oh, I know I'm 6 miles from shore and I can't see the shore anymore. Visibility is less than 6 miles or whatever it is. So you can determine your visibility by, you know, a weather service or by a known object that's at a certain distance. And when you apply your visibility to your nominal range, and there's a graph that I will show you, that is what we call your luminous range. And your luminous range is what we're comparing to. Like our luminous range is what our goal is, especially if you are taking a Coast Guard exam. You're looking for your luminous range. The third one is our geographic range. So again, is that light really high or really low? Are you in a kayak or are you on a large cruise ship that you can see further and further out? Like you have a bigger horizon than if you were just on a little kayak or something. So we have our geographic range that even if it's a super bright light, if it's really low and I'm really low, I'm still not going to be able to see it until I get over the curvature of the earth and am within my geographic range. So here's our example of geographic range. So for our light here, we are saying the light is 150 feet. So the horizon of the light is this far, that if I'm somewhere right here, right on the sea, the surface of the water, I will just be able to see the light at 14.3 miles. If I have 5 feet as my height of eye, is what they call it. If I am 5 feet above the water in a rowboat, I've extended that 14 nautical miles to 16.9. I've extended it by 2.6. If I'm on a small ship with a 30-foot height of eye, I've extended it by 6 feet. So I have, you know, a 20 plus mile geographic range. If I'm on a large ship, I can see it even further. I've extended my horizon almost 10 miles and I can see it at 24 miles. So it all depends on the height of the light and the height of eye that you have for you specifically. So it's always good to know what your, you know, typical height above the water is. So you have your height of light and which is given to you, right? Your height of the light is going to be given to you on the chart. And then you should know how high you are above the water. And you can apply those two numbers to see geographically, your geographic range, how far can you see this specific light? So there's different ways to figure out that number. You can use, there's, I would say, okay, the table, geographic range table, is in the light list. So it's pretty straightforward. You know, if you have a 50-foot light, your distance that you'll be able to see it is 8.3 miles. If you have a 20-foot light, the distance you'll be able to see it is 5.2. So how you apply those is apply the height of the object, add the height of the observer, whatever your observer height is, and you add those numbers together and you get the computed geographic visibility. So pretty straightforward on calculating your geographic visibility. Again, you're kind of calculating the horizon for the light itself, and then the horizon of whatever you are on, and you're adding those together. If you don't have that chart, you can use the formula, which is 1.17 times the height, or the square root of the height. So square root of the height of light and the square root of the height of I gives you your geographic range. That's the Bowditch formula, if you were to use Bowditch. Okay, so that's your geographic range. Then we have this luminous and nominal range, where you have the intensity of the light and the visibility in the area. So your nominal range is given to you on the chart. It is also given to you in the light list. And that's, you know, in perfect visibility, meaning 10 nautical miles, how far can you see that light? So some you can see less than 10, some you can see more than 10. It's just giving you that visibility of the light at perfect visibility, meaning 10 nautical miles. Then you use the luminous range graph, which is in your light list. If you are studying for your Coast Guard exams or you're calculating your luminous range, I would just Google it and print it out so you have it on a piece of paper, because it's kind of shrunken in the light list. And there's a lot of lines on it. So I would print it out and enlarge it. I think I have a copy of one I could add to the Google Classroom. Anyways, so you go into this chart. It's a little bit weird to use here, but we have our nominal range at the bottom. So if the chart said, I can see it at 15 miles. So that's saying in perfect visibility, meaning 10 nautical miles, you'll be able to see this light at 15 nautical miles out. Then your visibility are these curved lines. So these curved lines are your visibility indicators. So whether you've calculated them yourself or you have used your app or weather service to say, hey, visibility in the area is only 5 nautical miles. I'm going to find the line here that says 5 nautical miles. So this one says 5.5, we'll use that. So if our nominal range is 15, but it's pretty foggy out and my visibility is only 5 nautical miles, I'm going to follow that line up to the curve of my 5 and then go directly over to see what my luminous range is. That says my luminous range is going to be in between 8 and 10. So I'll go with 9. So this gives us 3 different numbers, right? Our luminous range is 9 nautical miles. So I should be able to see this at 9 nautical miles. Even though the chart indicates 15 and my visibility is 5, that's saying that the light is shining through the fog, right? Even though visibility is only 5, I can still see a light through the fog. I can still see a light through the haze. And by how far is by using this chart, which is going to be by 9 miles. Kind of a weird thing to think about, but just like a car. So when you think about visibility and you're driving in your car and it's raining, you can see an oncoming car's headlights before you see the car itself. So the visibility is telling you when you can see the physical car itself or that physical light. But because it has a light, and that's why we put our lights on when we're driving in the rain, we can see that car further out. In perfect visibility, that's our nominal range. We're going to see the car and light at the same time. But our visibility is 5. We can still see that light at 9 nautical miles, even though perfect visibility would be able to see it at 15. Okay. So what is the real visibility of the chart, or real visibility of the light? We have our geographic range and our luminous range. Whichever one is smaller is the soonest that we will see the light. So if we had calculated why this is important, right? Why am I even talking about this? If we've calculated, hey, I'm going to see Judith Point light at 10 nautical miles, and I think that's going to be around, 2 p.m. Well, it's 2:30 and I still haven't seen it. Am I off course? Am I closer to land? Or maybe it's, 1 o'clock and I see the light. Am I closer than I think I am? Did visibility change? These are all things you want to be like predicting along the way. When am I going to see this light? What color is it? What does it look like? All those kind of things. If it happens or it doesn't happen, if it happens before you think it should, or it doesn't happen at all, those are both super important indicators of, hey, I need to figure out where I am. Maybe I should slow down and get another indication of my position, because I'm not seeing what I'm expecting to see. So we always want to be, predicting and expecting to see things. And if it doesn't happen, or it happens too soon, then we need to reassess our situation. So if our geographic range is smaller, then that's our limiting factor. If it's, bright light, great visibility, but we're really low, our geographic range is when we're going to see it. If it's super foggy or low dim light, our luminous range is when we're going to see it. So which one is smaller? That's our limiting factor. So I do go into 2 examples here of calculating the light, but I am just going to leave that. You can look at it during the break, but it is already 8:05. So let's take a 10-minute break and come back at 8:15 so we can dive into our plotting tools. I know that was a lot of information on aids to navigation, but there are a ton of most likely much better YouTube videos out there about aids to navigation, and a lot of different little handouts. So check those out. If you're interested in calculating your range, you can look at this example. I'll leave it up for you there, but is also on the, you should have the PowerPoints on the Google Classroom as well. So let's come back at 8:15. I'll put that in the chat. And we'll start with our plotting. So have assignments 3 and 4 and your training chart out. I'll be back. How you guys doing? Ready to get started again?
Yep.
All right. All right. Well, like I said, we're going to dive into using our plotting tools now. So very exciting for a lot of us. And I, just talked for like an hour on aids to navigation, but we really aren't going to talk about aids to navigation much from here on out. We're going to talk about the symbols on the chart and identifying, the buoys and the versus lights and those kind of things. But the whole buoy systems and that, we really don't touch too much on. So if you guys want to have more information about it, I'd be happy to, you know, recommend a couple books or maybe some YouTube channels or something. But we're gonna move forward and go to plotting tools. So hold on, I'll let my dog out. Go. 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 Sorry. So we're gonna do plotting tools. Try to bring it. We'll go through the PowerPoint and then we will dive into my document camera and start working on assignment 3 and 4. So let's get it started. So our first thing is measuring lat and long. So there's 2 ways we go about this, or we want to know about lat and long. One, by seeing an object on the chart, whether it's a buoy or an island, the entrance, whatever it is, seeing an object on the chart and then writing down the lat and long. But also getting our position from, you know, a GPS unit or something where you have the lat and long in numbers, and then being able to transfer that information onto the chart so we can see where we are. So that's, I want to say, our real key, but we're going to practice that by measuring what the latitude and longitude is of different buoys and lights and things around the chart. So we're going to also be familiarizing ourselves with where these things are on the chart and measuring those lat and longs. So how to measure your latitude and longitude. So remember, on our charts, we have the degree is not repeated every time, but we have the minutes every 10 minutes, or 5, so we have, no, it's 10. 20 minutes of latitude, and then is marked at 25 minutes, 30 minutes, et cetera, et cetera. And then each little kind of a black and then a white and then a black and a white is 1 minute. So this is our 20, 21, 22, 23, et cetera. So how do we find where this buoy is when measuring the latitude and longitude? So our key principle that we are going to think about is kind of thinking about when you are trying to hang a picture or create a parallel line that is parallel to already line, whether it's the ceiling or your fence or, you know, you're drawing something, whatever it is. If you want to make a parallel line to a line that already exists, one of the quick ways of doing that, you don't have an instrument, is to measure the distance. You know, if you measure 10 inches from the ceiling down, 10 inches from the ceiling down, 10 inches from the ceiling down, and then you connect all of those dots, that line, that parallel line, is going to be 10 inches parallel to whatever you are measuring from. So we're going to use that principle when we're measuring our latitude and our longitude, because every couple degrees we have this bold line, this latitude line or longitude line on the chart. So for latitude, it's every 10 minutes. So we have one at 20, we have one at 10, and one at 30. And then for longitude, it's every 10 minutes again. So you have these bold lines. So we don't have to transfer, we don't have to parallel our line of longitude or line of latitude all the way across the chart. We only have to do it to the nearest bold line. And if it's connected to a bold line, then we can see what it is all the way across the chart. So we're just trying to make it a little simple for us. So if I want to measure latitude, I can draw in my latitude line to my nearest bold line. So here's my latitude line to the nearest bolded line. So the distance here, anywhere along that line, directly to the buoy itself and all the way to the edge of the buoy, is going to be the same because it is a parallel line. We are drawing this parallel, perpendicular line, and anywhere along that line, it's going to be the same. So you don't have to draw a latitude or longitude line all the way across the chart. We're only drawing it to the nearest bold line. So same with longitude. We're going to draw our line and we're going to parallel it to, our other longitude line. We draw in our longitude line, but we don't have to draw it all the way across the chart. We only have to draw it to the nearest line, and then we can measure that distance and bring it down to measure what our longitude is. So we are going to practice doing that, and I will show you on let me show you how I do it on, let's dive into course and distance, and then I'll get to the document camera. Another way of getting, so our line here is exactly, parallel to our bolded latitude line. Another way of doing that is by swinging an arc. And if you get a tangent, meaning it only hits the line once, it's the closest possible distance, or the closest possible, direction distance to that line, it will be parallel as well. That's just one other way to do it. Most people don't do it that way. But if you see someone doing it that way, or you learned how to do it that way, great. By all means, keep going. And I will show you that on the chart as well. But again, we're just making these parallel lines and then bringing that information to the edge of the chart and measuring, getting what the latitude and longitude is. For measuring courses. So our courses are our streets. These are what we are creating. So some areas on the chart will have the traffic lanes, but you will definitely need to draw in your courses to get to those traffic lanes. You'll need to draw courses at wherever you're going. You want to make sure that you have a destination, that you're not just going out there and then you run into something. So even if you're like, I don't know really where I'm going, I'm just headed in this direction, make that a street and then check that street for hazards. Anytime we make a street or a course line, track line, whatever you want to call it, on the chart, we always want to check it for hazards. So, however far your hazards are, that's up to you. An inch or two above or below the line, maybe a couple inches, whatever, that's up to you. But you want to follow along that track line or that course line, whatever you're going to call it, and see if there's any hazards. Is it too shallow? Am I crossing a traffic lane? Am I going through a, sailing regatta? Whatever it is, you want to make a note of what you're going to be seeing along that way. So once we draw the line, we check for hazards, then we want to read what the course it is so that I can steer that course or etc. So what is the course, the direction of that line? And that's how we're going to indicate different lines, is by what their course is, what direction it is. So if we remember, north is 0. And then if we go clockwise, we go by degrees. So due east is 090, due south 180, due west 270, and then back to north is 000. So you have 360 possible degrees, and we're going to label each line that we draw with the indication of where it's pointing to. So we have, you know, the start point and the end point. Where is it pointing to? We want to give it a value, and that value is going to be in between 0 and 360. Anything that we put on the chart or anything that we read from the chart is going to be in true, and that's in degrees. So we have our true compass, we have magnetic compass, and we have a ship's compass. So we have 3 different compasses, and we're going to dive into that next week. Next week is all about compass error and differentiating between our 3 types of compasses. But for today and for the rest of class and the rest of time here, anything that you put on the chart or that you're reading from the chart is in true course, is relative to true north, which is pointed directly up. So all of those vertical lines are pointing directly to north, and then we're going from that north how many degrees, you know, clockwise, and that's going to give us our course measurement. So another thing we like to do as recreational boaters is have something to aim for. Even if you have a autopilot on board, and you're steering by hand, whatever it is a lot easier to steer by hand when you're looking at something on the horizon or something in the distance rather than chasing a number. If you're trying to steer 090 and you're like, oh, 084, 092, and you keep going back and forth, you're going to have a lot of those squiggles. If you have something, a buoy or a light or a jetty or something in the distance, you say, okay, I'm aiming for that, and you steer for that, you're going to have a lot steadier course. So it's typical that you will see our courses and our exercises here going from buoy to buoy or buoy to light. That being said, don't hit the buoy. You're not actually going to the buoy itself. But in this class, we go a lot of times from buoy to buoy. So that's my little caveat. Don't hit the buoys or the lights, but we're going to aim for them. Okay, so we have 3 tools that we are measuring. So we have a course that we drew from a buoy to a buoy. It goes across the chart, and I want to measure the angle of it. I want to know what the degree measurement is. So using one of the tools, so in this case, we have our roll plotter. So that's going to be your plastic roll plotter with the little metal thing at the bottom. And you're going to line up the edge of that roll plotter on the line in question. So you're just lining it up perfectly. There is a black line. I will show you guys on the chart, on the document camera. So you're going to line it up perfectly and then parallel it, meaning just move it across the chart to a compass rose. So you are aiming for one of the compass roses on the chart. So just like the little animations showed us, we're just going to parallel it up to the chart, and then we start it at the center of the chart, or the center of the compass rose, excuse me, compass rose, and you're measuring to the outer circle, and whatever number that is, that's the number, that is our course direction. So you're going from the center, that little cross of your compass rose, to the outer circle. And that is going to be our true course. Same type of thing if you have parallel rulers. Going to be these. Again, I'll show them to you on the chart. But you line it up, pretty straightforward. You line it up on the line in question, and then you just parallel it up to the closest compass rose. Now your triangle, if you guys have triangles, your triangle doesn't need a compass rose. So that is why I prefer the triangle, because I would say 70% of the time you don't need a compass rose and you don't have to move it at all. So there's no jiggle. But you line it up on a vertical line. Again, that vertical line happens every 10 minutes of longitude. So if you line it up on a vertical line, meaning the long side of your triangle is in line with whatever course you are at. The middle of the triangle, which I'll refer to as the focal point. Some of the triangles have an actual dot there, but it's the exact middle of the triangle. You'll be able to see it, is the focal point. If you line that up on a vertical line, then at the other end of the vertical line, you can measure the direction of the line. So this is about 60, if you look at it close, it's about 65 degrees. So from here to about there, it's about 65 degrees. That is your triangle. Again, I will show you how to do that on the chart. I prefer the triangle because you don't have to move it. But the parallel ruler and the roll plotter are a little more straightforward, right? You just have a line and you're paralleling it to a compass and reading it. So I feel like that's very user-friendly for beginners. But once you figure out how to use the triangle, you'll never go back. You'll always use the triangle. So if you have a triangle, now is a great time to practice. If you've never used it before, but definitely if you just have a parallel ruler or roll plotter, use those. Those are great too. Okay. So that is measuring course. Then we have measuring distance. And measuring distance, we are going to our miles scale. And again, 1 minute of latitude is equal to 1 nautical mile. So we measure from point A to point B using our dividers. And then you bring the distance that you just measured with your dividers over to your latitude measurement. And 1 minute of latitude is 1 nautical mile. So then you could quickly measure your distance. If you have triangles that don't reach, or you have a long line across the chart, it's going to be what we call walking the line. So you first measure a certain distance, maybe 5 nautical miles. I think these typically go to 7 is the max distance. And then you can walk your 5 nautical miles, and then measure the last. You add them all up and you get what the distance is. So you just divide it along the way. And we will go over that too. So let's do some demonstration.
Actually, I have a question. Is my mute? Yeah, it's on. This is Barbara. Can I ask you a quick question, Bree? So 1 minute of latitude equals 1 nautical mile. Is that what you said?
Correct.
Okay. But you can only use that and not walk the distance when you just have a totally vertical line, right?
No, you can use it. We're going to use it always. So,
But I mean, if you look back at that sample you had a couple screens ago, one of those arrows was, you know, it was listing to the, it was pointing off to the right.
to the right, yes.
Then how could you use the vertical on the side to determine those nautical miles?
So here we go. Let's draw in. Here's a buoy, and here's another buoy. I'm going to connect these. Can we see that line on the chart, right?
Mhm.
So if I want to measure distance, I'm going to use my dividers to say my distance is from this buoy to this buoy. And then I'm going to use this distance and I can measure it anywhere along this chart. So if I measure from here, that's at 15. So I have 1, 2, 3, 4, 5, 5.7.
Okay, I
Is
thought
my-
you were suggesting not using the measuring tool, just going off to the side and seeing where the,
So
going from here to there and just going literally across,
we
using the tool that's in your right hand.
yeah, we want to use the tool
Understood.
to measure the distance,
No,
and then
I
we bring that tool
bring it over to the side. Okay, I get
over
it.
to the side.
I missed that you said. I thought you meant you just literally went to the side. I thought, how could that be? Okay.
Okay, so I'm going to get down a little bit so we could see both sides of the chart here. So let's, I don't know. I'm making a position. So for latitude and longitude, you can see the camera, but that's okay. For latitude and longitude of this random position here, I want to draw in my latitude line and my longitude line to the closest bold lines. So I have this bold line here and this bold line here. So I want to go to the closest bold lines. So if you're using a parallel tool, you want to line that up on a parallel line. So I have this bold line right here. I'm going to put this has a dark line. You can use the edge, but sometimes depending on how thick it is, it can give you a little bit of, I don't know, refraction or whatever. So I like to use the black line that's on all of your tools. So I'm going to put that black line on my known latitude line, and then I'm going to parallel it up to let me do it from this one just so I have it straight. So I'm going to parallel it up to my position or my buoy, whatever I'm measuring, and then I could draw in my latitude line. So I know that that is my latitude line. I'm going to draw in my longitude line. So I'm going to line up this vertical with a known vertical line. And then I'm going to bring it over to my point in question and draw in my latitude line, my longitude line, excuse me. So this is my latitude and this is my longitude. In this case, because I'm so close to the edge, I could have just drawn it over. That would have been easier, but I'm just making the point of you don't have to draw your latitude line all the way across the chart. You only have to draw it to the nearest bolded lines. And then I'm going to use, if I want to measure my latitude, I can measure using my dividers here. So this distance is the same all the way over to the edge. So I am pretty much exactly on 41 degrees. This is 10, 11, 12, 13, 14, 14.0 minutes north. That is going to be my latitude. As I went measuring this, going all the way across, line it up a little bit better. And we are at 41, 14.0. To measure longitude, I'm going to do the same type of thing. Get our measurement. It's the same measurement all the way across the chart. So in this case, let me put my pencil there. If we can read it, here's our 7130. Here's 7125. So we have 26, 27, 28, and 29. So we have 27. So I'll write it down. We have 071 degrees, 27. And then if you could see, we have a 27 here. And then there's 10 little marks. So this would be 0.5. And then I'm 1 mark over. So that would be 0.5, 0.6 minutes west. And that is my getting a latitude or longitude position. Now, using different tools, so that was using the roll plotter. If you want to use a parallel ruler, you can put your parallel ruler. There's 2 types of parallel rulers, actually. Some have the black lines, but some do not. If you're using a parallel ruler, I'd recommend the ones with the black lines, just because I like that. So I put up the black line exactly on a latitude line that I know of, and then I keep pressure on the one that is on a known latitude line, and then I could move. Oops, I jiggled. You're going to get to jiggling a lot tonight. So I'm going to put pressure on this one, and then I can move this freely, and anywhere along this line is parallel to this ruler. So I'm going to bring it up to my position in question and then draw in that latitude line. Same with the longitude. So in this case, if I'm measuring my longitude line, my position is underneath my glass here. So I prefer not to use the back side of the ruler just because I don't know if it's exactly straight. I would move this one further away. Don't have my document camera. And then put pressure on this guy. And then parallel this back until it gets in line with my position. And then I could draw in my longitude line. Now, for the triangle. For the triangle, you don't have to do any paralleling. or moving or jiggling. I want to draw in my latitude line, so I use the perpendicular. So this is my latitude line. This would be a perpendicular, exactly 90 degrees, which is our latitude and longitude lines, right? It makes a nice grid. So I am going to put my pencil on my position in question, and then I'm going to line up that vertical, that 90-degree perpendicular line on the vertical line, and then draw in my line. So no moving involved. Again, for longitude, I put my pencil on it, bump up my triangle against it. I line up my vertical line here. I got my big belly here, so it's bumping. On the horizontal line, and then you can draw in an exactly parallel line. So I like those ones a little bit better. Again, because these training charts have these Loran overlays, your eyes can be you're like, oh, that's totally a straight line. And it can totally not be straight. So the whole optical illusion, mind bending lines can definitely happen. So you want to be as accurate as possible with your tools, and that will make your measurements more accurate. So to go for, let's see, let me put it on a Post-it or something, and we can see. There we go. Let's draw in, we're reading on our GPS 41 degrees, 16.4 minutes north, and 071, 22.7 minutes west. I have no idea where this is, or I know it's somewhere in here, but we are reading this on the GPS, and I want to know where I am on the chart. So that's the other big reason we want to practice our latitude and longitude. So using my triangle, I'll do it both ways here, but I want to go to 16. So here's my 15. Here's 16. Here's 17. So I want to go to 16.4, which is going to be just one little tick below that 0.5. So that's my 0.4. And I am going to draw just a little mark on the bolded vertical line. Put that a little bit further up. So this is my latitude line. Yeah. So now this, or I'm getting distracted with myself. How I would have done this is measure my 16.4 using my dividers. I was trying to take a shortcut because I was so close to the end of the chart. So 16.4 is right on my chart, and then I go to the nearest bold line. So my bold line is at 20 and 10. So my closest one is going to be here at 20. So if I have this and I go all the way across the chart, all the way, it's going to be the same line. So I'm going to mark it on this vertical line. I did already mark it on that vertical line, but I'm going to mark it on this one. If you have Where is it? If you have the tool that has a pointy end and a pencil end, that makes it very easy. If you measure your distance there, you can just, your pencil's already connected to it. So you can just swing a little pencil line. So if you have the divide or the compass, that's what this is called, a pointy end with a pencil end. The pencil's already on there, so that's convenient. Okay, so I'm going to draw in my latitude line using my divider or my triangle here. I'm somewhere along that line. Again, if I had a parallel, I would do the same thing. I would measure my 16.4, go to whatever my closest vertical line is, make a little mark, and then I would go from the one I just did, parallel it down and draw in my line. So same thing with the rulers, you're just paralleling the line. Then I would go for my longitude, which is 22.7. So I have 0, 7, 1, 21 or 20, 21, 22, 23. So I'm going to 22.7. So we have the 0.5 and then 2 past would be our 0.7. And then if I just bring this up to the line that I already drew, this right here would be my position. If I want to draw that in, I bring that distance here to a bolded line. Put a little mark. Again, if you have your compass, you could use that. Vertical line. Is this vertical line? No. And there is where those two lines cross. That is my position. And then you can erase, your lines and just keep what you did right there. So that is plotting a position. Okay. Then let's go to the course line. Let's stop. Any questions with plotting or with plotting a position, whether you are given a position or you have a position that you're trying to find on the chart? Does anyone want another example of using the different tools? Okay. Let's dive into the course line. So if I am going from point A to point B, going in this direction, I want to measure the angle of this course. So let's start with our roll plotter. Again, I'm using that black line and measuring it exactly on the line that I just drew. So I line it up on the line that I just drew, and then I'm going to push down on that metal part, and I'm going to see where it crosses my compass rose. So my compass rose, move this over a little bit. Here's my compass rose. I'm going to bring it to the center of the compass rose. So I can put my pencil there so I know exactly where it is. And I bump up against it. And then I can draw in my line. You don't have to draw in your line. I'm just doing this as an example here. But this is a parallel line to that course that I just drew. So then I could see from the outer circle, which is our true, we have 0, and then we're going to go in between 50 and 60. I'm going to call that 058. I'm going to say 058 degrees true for going from this buoy to this buoy. So that's how I'm going to label this line. It's 058. Now, if I was going from this buoy to this buoy, I would be on the other side of the compass. So my starting point in the center, and then I would be going in this direction. So I would call my course 238 degrees true. So again, that's, here's our north. There we go. Here's our north. 238 degrees from north gives us that direction. So you can quickly see the number and kind of place, I like to say, which quadrant you are in. Are you going, northeast? Are you going southeast, going southwest, or northwest? Generally speaking, which quadrant, when we have our 0, 090, 180, and 270, what direction am I going in, and does the number that I'm getting correspond with it? So just a good way to check that you're not on a reciprocal course or something like that.
I have a question. This is Barbara.
Yes.
Let's say like there was, let's say you're way down there, that Block Island. Is it Block? Yeah.
Yep.
And then you're going to go in a straight line. Pick one that doesn't have any land in the way. All the way over to the right side of this chart. All the way.
Yep.
So how do you
get there? Yes, that is a
get there. How do you
draw in the line?
Yeah, how do you do that?
Let me pause on that. I'm going to answer that question, but I just want to show you the other nav tools as well.
Okay.
But I definitely will answer that question because we are going to see that on our homework.
Okay.
So parallel ruler, again, you line up your black line with the line in question, and then you bring it to the center of the compass rose, and you could measure the line. So again, here I missed the top of the compass rose, so I'd have to remeasure. That happens a lot with the roll plotter too. Sometimes you miss the compass rose and you have to remeasure, or you jiggle along the way. So there's just more movement involved in these two tools. If you use a triangle, let me get the clear one. This one's a little easier to see on the camera. If you use the triangle, there's no movement involved. So I want to measure this line. I'm going to put the focal point of the triangle. So our triangle has a long side and two short sides, and then it has a focal point. So I'm going to put that focal point on a vertical line. So any vertical line, it's not really a vertical line, is where I put my focal point. And then whatever course line I have, wherever it is going to be where the long side of the triangle is. So I'm going to put the focal point on a vertical line and this long side of the triangle on the line in question. So if you guys can see that, we have the long side of the triangle in line with my course, and then I have my focal point on a vertical line. So on the bottom here, I'm going to read the numbers to get my course line. So I am in between 050, 060, I'm about 2 degrees in. So I have my 058. Now, if I wanted to go on the reciprocal course, I'm reading the numbers above it. So I have 240 and 230. So I'm in between 230, 240. I would call that 238, which is what we measured on the compass rose. So this one just didn't have any, moving involved. Some of your triangles, this one is tinted, so I tend not to use it, but the reciprocal courses will be in red instead of, and then you have your other ones in black. So that's what the two numbers mean. One's a reciprocal course of the other. Also on your triangle, for those using triangles, you have two sets of lines. You have these little ticks on the outer side of the triangle. Those are your degrees. So there's essentially 180 of those, and it's like folded in half. So you have your 360 degrees. These ticks right here are associated with your, also called cardinal signs, or your cardinal directions. So your northeast, west, southwest. And then these little ticks have the point system. So that's where you get your, west, southwest by west, or by east. And each of these is equal to 15.25 degrees. No, 32.25 degrees. What is it? What is a point worth? Anybody know? Robert, you must remember this somewhere.
11.25, I think.
11.25? Okay. Something. Anyways, these lines, these ticks will not equal these ticks. So you don't want to line up one of these and think that it's in line with one of these. They will every 4 degrees because it's 0.25, but it won't happen on all of them. So some people get confused on that on the chart, or on the triangle. Another thing I want to mention before I answer Barbara's question there is on both of your roll plotter and your chart, on the long side that we are measuring our course on, there is a distance scale. So we have where it says 1 nautical mile, and it has 1 to 80,000. So if our chart matches the same scale, which both of our charts do, both of our charts are 1 to 80,000, then we can use this edge of the chart as a distance indicator. So that is just another way, but it has to be 1 to 80,000. So if you are zoomed in or zoomed out, this scale doesn't work. So again, on the triangle, we have 1 nautical mile for 1 to 80,000. If it's not that, then the scale doesn't work. So I tend to try to lean towards always, for measuring distance, always use your latitude to measure distance. So you measure from point A to point B, and then you measure your distance. That will always work. There are little shortcuts that you can learn along the way. That is one of them. But again, it only works if you're matching scales. Okay, before we dive into the question, let's see. If you want to go a long distance, what you do essentially is extend out your chart. I always like to recommend getting a ruler. Your 18-inch ruler is great because it's not too long, but it does help. If you are keeping your nav tools on the boat, I always like to throw in a yardstick just so you can do those nice long distances. But again, maybe you don't have a yardstick or a ruler. So what you would do is use your nav tools. Hopefully you have more than one, and extend it out. So if I want to go from this buoy over to over here, from over here, I can't reach, right? So I need to extend out. I can use another tool. You can use multiple tools. We do this one a lot, where we measure. Let me make my camera bigger real quick. Stand by. Okay. Okay. So we want to draw across the chart. We can use a ruler, but I think in our homework assignment, we do one of these where we're going across the chart. So I like to extend out a line by using a couple triangles, or a triangle and a roll plotter, and what's the other one I want to use? You can also use the edge of your holder for your compass. Most of you guys have that with you. You can extend something out using any sort of straight edge, whatever you have. If you want to go from Block Island to Breton Reef, whatever line this is, I'm going from this light here to this light there. And when I draw this, so I'm lining up the angle using an extended line, whether it's triangles, whatever sort of straight edge you have. But when you draw it, you want to draw it on the same instrument the whole time. So what that means, okay, is I'm going from this buoy to this buoy, is now that I have the angle, I have pressure on this triangle. So when I draw it, I can draw the line. And then I want to draw it along the same triangle. So I'm now going to put pressure on my ruler, slide this down. I just bumped it, so now it's not going to be the same. Continue the line. Slide this down and continue the line. So I always drew my line with my pencil against whatever instrument it is. If you don't, it's not like a huge deal. Maybe it's just a pet peeve of mine. You could end up getting a line that looks like that. A little bit, drawn on one triangle, a little bit drawn on the other, depending on, your pencil, your mechanical pencil, whatever it is. So it would be less accurate than if you just drew it along the same instrument the whole time. Does that make sense? So to answer your question, Barbara, it is a creative way of drawing a line across the chart. But I think you have a couple homework assignments or a couple problems where you are drawing a line across the chart. You know, you can get a yardstick at Staples for like $1. So I would definitely recommend keeping one, especially if you just keep it in your chart tube. It's the same size as your chart, so you just keep it in your chart tube. Or you can get creative by extending out a line.
That's a hassle doing it that way. I think the
ruler.
the yardstick is better.
Yeah. I would say even if you just have the 18-inch ruler, that does help, covers a lot of it. But yeah.
Okay, thanks.
I guess I talked a lot here, so we only have about 15 minutes left. Do you guys have any questions? We can start on our homework assignments. Any questions, or you want me to show you anything else before we get started on homework? Okay. So let's dive into assignment 3. So this is also, again, going to be that chart familiarization. If you, I mean, most of us will have no idea where any of these things are. So you can look at the answer sheet and ballpark. You know, this one says Point Judith is 4120 something and 07128 something. So I could look, you know, at the bottom of my chart, I'm looking for 02128. So I'm going to be on the end of the chart over here somewhere, and my latitude is going to be 4120-ish. So I'm going to be generally speaking over here. Here's my Point Judith light. Really, that's the best way to find the ones that you have no idea where they are. Because I don't want that part to be frustrating for you on this homework assignment. I would, you know, I'd go around and show you where they all are, but I'm not there with you. So we have Point Judith here. Let's get the latitude and longitude. So using my triangle, I'll zoom in on this.
Oh no.
We'll get back here. Hold on.
Hold on. Oh, I thought that was me.
Oh, this is me.
My laptop's messing up right now for some reason. I
Okay.
missed something you said.
Okay, so here's our Point Judith. And I want to get the latitude and longitude. So my quick way of doing that, I put my pencil on the light. So this is a light. Remember our difference. We're looking for a solid dot with the magenta teardrop, or for a light, or an open dot with a diamond for the buoy. So we're looking for a light, we're looking for the solid dot. Where that solid dot is where I want to measure. So here we have our Point Judith light with our little black dot. I am going to line up my vertical line with my vertical line and draw in my latitude line. Now I'm already on the edge, so I'll just mark that. For my longitude, I put my pencil, bump it up against, line up my perpendicular line on the latitude line, and draw that in. So I have drawn in my latitude and longitude line to my nearest known bold lines. Then I'm going to use my dividers, measure my latitude, same distance all the way across here. So I have a latitude of 41 degrees, 21 point something. So I have 21.567. So 21.7. So it was 41 degrees, 21.7 minutes north. For my longitude, I get my measurement, bring it all the way down. From my 071 line, right? That's the line that I measured it from. I am at 28, 29, just shy of 28. So I'm going to call it 28.9. So I'm going to write that here. 071, 28.9 minutes west. I know this is sideways. Remember, we always want to put that placeholder in for longitude, 071. That way we know that that one's longitude and that one is latitude. We also put our placeholder of east or west and north and south. Okay. So that is number 1 on the latitude and longitude. I'm going to quickly do number 1 on the course and distance one. Just so I can show you before class ends. Okay, let me move this a bit. Okay. So on assignment number 4, number 1 is going from, what is the course direction from buoy 2 off of Point Judith? So here's Point Judith. Buoy 2 is going to be this buoy right here to Breton Reef Light. Breton Reef Light we're going to be using a lot. Here's our Breton Reef Light. So we are going from a buoy to a light. That will help with identifying which, mark it is up there on the light. So we are going to connect the dots. Here's the light, and here is the buoy. So we're just going to connect the dots. We drew a line. Anytime we draw a line, we want to look. Looks like deep water, but we are passing very close to a buoy. So we want to make sure we're not hitting this buoy as we head for the light. Just to mentally note. But it's just an exercise. We're just going with it. Okay, so what is the course and distance? Let's start with this distance because that's going to be straightforward. So we're going to measure from our buoy to our light. So I just have the distance on my tool. And then I'm going to go over to the edge. There we go. And measure my nautical miles, which are in minutes. So we're starting at 20. Here's 5, 6, 6.8 nautical miles. I'm going to say my distance is 6.8 nautical miles for this leg of our route. Now for course, you can do it 2 ways. You can parallel things, back to your compass rose here, or you can use the triangle. I'm going to do the triangle first. So I'm putting the long side of the triangle here on the line in question, and then I'm going to put the focal point on a vertical. This is a very short leg. It's not actually crossing a vertical line. So I just get the tail end down here, but that's going to be okay. So I have my focal point on a vertical line, and I have the long side of the triangle on my line in question. I could read at the bottom, right in between 030 and 040. Why do I know it's not the 21022? Because I know that I'm going from this buoy to Breton Reef. So I'm going in the northeasterly direction. So my number is going to be somewhere between 0 and 90, right? Because that's our range, 0 to 90. So I'm going to follow the 030 to 040 line and call it 035. My course, 035 degrees true. If I am using a roll plotter, I'm going to measure the line in question with my black line there. And then I'm going to put pressure down on the metal part and roll this to the center of my compass rose. I'm going to put my pencil on the center to just mark it. And I see on the outer edge, my course is 035. Same thing for the roll or the parallels. We're going to put that edge, that black line on the course in question. Then I'm going to put pressure on one ruler. Now I can move this ruler freely. I can't make it all the way to the triangle or all the way to the compass rose. Then I switch pressure. I'm going to put pressure on this ruler. And now I can move this one freely. So it's kind of a dance of which one has pressure, which one doesn't. So I'm going to close the rulers again. Then I'm going to put pressure on that north one. And now I can move this one freely, and it can reach the center of the compass rose. And I could draw in my line and read. You don't have to draw on the line. You can just read it if you want. I guess when I'm using the compass rose, I like to draw on the line. But that is just another way to do it. So that is your course and direction for each of those for your Breton Reef assignments. Now for number 2, so you're not totally frustrated with me. looking for buoy 11. And that is going to be this green buoy 11 right up here. We're going from Breton Reef to buoy 11 near Bull Point. So here's Bull Point, and our buoy 11 is this green buoy with the light. It has a light on it, so it's the buoy that has, can't draw a diamond, that has the diamond color, or the magenta stamp on it, because it has a light. So that's the buoy that we're going for. On our assignment, what did I want to say? These ones, the first half is kind of individual, and then the last 4 are going to be kind of following one another from making a little voyage all the way across the chart. So we do have a big 32-mile spread where you'll need that ruler or that yardstick or something like that. Other quick questions I usually get. I'm not sure. I'd say for the latitude and longitude one, look at the answer sheet to just ballpark where it is, and that will help you significantly in saving time searching for random buoys. So definitely do that.
Bree, can I stop you there with a question? This is Barb.
Yes.
On assignment 3, question 1, it's Judith, Point Judith. Well, Point Judith is pretty easy to find on this map. But you said something, maybe I misunderstood it. I thought you said, oh, when you don't know where something is on a map, here's kind of a rule of thumb, easy way to find it. Did you not say that?
I did. So especially for those of you testing, if you just have Point Judith light and you don't have the answer key in front of you, and you have no idea where this is, and you're gonna find it, look in the light list.
Oh, okay.
So our light list,
it's on the chart here, you're saying.
no, the light list is a navigation pub.
Got it. Okay. Okay.
So if we look at our light list.
So what, do you got to Google it or something and online if you don't have that book?
Yes.
Okay.
Yes. What do we, Point Judith, right? P.
Yeah.
I'm just looking up in the index. Where is Point Judith light? Gives you on page, oh, I'm looking at the wrong thing. We should be looking in blue. Point Judith light. Point Judith light gives us a number of 18050. There we go. So on the light list, if you don't know where it is, you can look it up alphabetically and then find it in the light list. It gives us Point Judith light with a latitude and longitude. It gives us the light characteristics. It tells us the height, that's 65 feet. Nominal range is 16. It's an octangular tower. Lower half is white, upper half is brown. It also has a horn with a blast every 15 seconds. So it gives us, that extra information that wasn't just on the chart itself.
And what's that book you have again? What's the front of it look like?
So this is a training chart, right? This whole thing is a training chart.
Right.
So what I have here is exam room material,
Oh,
which you can get online, and I could put the light list
oh, that's all right.
on Google Classroom if you want. It's the light list and Toast Pilot
That's the one
for
Latitude,
for the
Latitude
training
White.
charts. And I'll add that to Bree's references on the Google Classroom. So it's
What is the
nice
longitude?
on when it's in PDF that you can just literally Control F, point Judith, and find it.
Okay, okay, okay.
So
Thank you.
I will do that right now.
Okay.
Yeah, let's see. Let's stop share. What other questions do you guys have? We kind of covered a lot today. We did cover a lot. But I will be around all weekend. Dog sitting my parents' dog, another little toy Aussie for those Aussie lovers out there. So yeah, if you guys want to Zoom this weekend or try to find something or go over how to use your particular plotting tools that you have, I'd be happy to do that. So I guess as a caveat here, I'll say that frustration is natural. You will, jiggle and have to remeasure and jiggle and have to remeasure along the way. But just like any sort of new skill or new thing, the more you practice, the easier it will be. So keep practicing, do all of the homework assignments and maybe do them twice. I mean, that's kind of excessive, but we will be from here on out, the answer to a lot of questions is just checked by what it was the latitude and longitude. And so you're putting in that latitude and longitude every single question, and you are getting used to plotting those Latin longs and those course and distances. So we will be practicing that a lot for the rest of the class. Also, it doesn't have to be, I would say, if you are in 0.3, so that's not, 3 nautical miles, that's 0.3 minutes of latitude or minutes of longitude, give or take on either, then you are totally fine. You are good to go. So it doesn't have to be, spot on exactly matching what mine does. But give yourself a little grace on that. What other questions do you guys have?
Triangle. Where did you get your triangle?
You can get the triangles at the boathouse.
You can't, really? Oh, Latitude? You mean OCC?
Yeah, OCC.
Oh.
They have all of the nav tools that I use. You could also get them, West Marine or Amazon.
Okay.
But yeah, they do have it down at OCC in the boathouse, or
Thank you.
whatever you want to call it. Yeah.
Thank you.
All right. Well, let me know if you guys have any questions, and I will see you next week. We're going to go over compass error next week. Lots of compass.
Okay, bye-bye. Thank you.
Have a good weekend, guys.
Bye.
Thank you. Bye.
Thank you. Bye-bye.
Thank you.